As you all know, FM radio is a very common electronic device which finds its use at various places. All it takes is rotating a knob and you are tuned to your favorite radio station. But have you ever wondered about the nitty-gritties of its working? Through this video, let's try to understand the circuitry of radio receiver. Radio receiver is an electronic device that receives radio waves and converts the information carried by the waves into a usable form, such as an audio signal. What would be the features required in a radio receiver? Firstly, it should be frequency selective, that is, it should be capable of accepting or rejecting another close carrier frequency. Next, it should be sensitive, that is, weak signals should be captured nicely. And lastly, the fidelity is an important feature. Basically, the messages signal should not get distorted and the output signal should be as close as possible to the transmitted signal. FM radio receivers can be methods of which superheterodyne receivers are most advanced and common these days. In superheterodyne receivers, there is an intermediate frequency lower than the audio frequency, that is, the baseband signal frequency in the FM radio. Its advantages include low cost and it's capable of filtering out unwanted signals. Let's understand the basics of an FM receiver via block diagram. The signal is intercepted by the antenna. And then the RF amplifier selects the FM spectrum of signal and amplifies the received signal. The amplified signal and local oscillator signal is then applied to the mixer stage. The mixer generates an IF signal which is then amplified by the IF amplifier. The output of the IF amplifier is applied to the limiter circuit which removes the noise. The output of the limiter is then applied to the FM demodulator. The demodulated signal is applied to the audio amplifier stages and then the signal is delivered to the speaker. Now let's understand each of these stages in detail. An RF amplifier. The amplifier which amplifies in the frequency range of 20 kHz to 3 MHz is called an RF amplifier. The values of capacitors and inductors are kept such that there isn't a high impedance for RF range. The complete RF range is quite wide and hence most of the RF amplifiers are of the tuned type and they are called tuned radio frequency amplifier. What are tuned radio frequency amplifiers? They amplify a specified frequency band which is applied to the amplifier only after selecting it by a suitable filter circuit. The two signals are delivered to the mixer. A mixer creates new frequencies, a sum and a difference from two input frequencies. The tuned and the amplified signal enters one port of the mixer and the signals from the local oscillator enter the other port. The sum signal is rejected by the low pass filter and the difference signal, which is the intermediate frequency, is fed into the intermediate frequency amplifier. Mixers are widely used to shift signals from one frequency range to another, a process known as heterodyning, the basic concept of our FM receivers. We use a double balanced passive mixer or a diode ring mixer for this purpose. Now, image frequency rejection is an important issue in FM receivers. In heterodyne receivers, an image frequency is an undesired input frequency equal to the carrier frequency plus the twice of intermediate frequency. The image frequency results in two stations being received at the same time, thus producing interference and undesired results. But fortunately, it is possible to remove the unwanted signal by the addition of a tuned circuit prior to the mixer. The local oscillator and RF amplifier are ganged or tuned together for this purpose. Now let's see what is an IF amplifier. Once the signals leave the mixer, they enter the IF stages. These stages mostly consist of amplification in the receiver as well as filtering, which enables the separation of specific frequency from others. Limiter is the circuit used in FM receiver to remove noise present in the peaks of received signal and to remove any amplitude variation in the received signal. The output of the limiter has a constant amplitude. Output from the limiter is fed into the phase locked loop demodulator. PLL can be used as an FM demodulator. It uses a negative feedback control system. There are two inputs to the phase detector. One for the reference signal, such as the synchronized oscillator signal, that is the VCO, and the other for the modulated signal, that is to be demodulated. Now let's see the parts of a PLL. Firstly, it's a phase detector. The output in the phase detector is a function of the phase difference between the two inputs. Another part is the VCO or voltage controlled oscillator. It produces an output whose frequency deviation, that is the carrier frequency, depends on the input voltage. A portion of this signal is fed back into the error detector by a frequency divider. The other input is a fixed reference signal. When the two single inputs are equal in phase, the error will be constant and the loop is said to be in a locked condition, hence the name phase locked loop. Hence, we obtain the demodulated. Now let's see what is an AF or an audio frequency amplifier. It basically is a voltage amplifier which amplifies the voltage signal which is demodulated. Power amplifier. The demodulated signal might be weak or strong. To receive proper output, there is an automatic gain control system which is fed back from the power amplifier to the IF amplifier stage. This is to regulate the magnitude of gain depending on the strength of the signal. That is, weak signals are amplified more strongly as compared to the signals which are already strong. Look at a circuit diagram of an FM receiver circuit. Firstly, there is a TRF amplifier, the output of which is fed into the mixer. The output from the mixer is fed into the IF amplifier stages, the output from which is fed into the limiter circuit, which is then demodulated. And after following the audio frequency amplifier stages, it is delivered to the speaker. Now, selectivity is an important issue in FM receivers. In many electronic devices, such as radio or television receivers, a particular frequency must be selected from a band of frequencies. In the radio frequency amplification stage, it accepts only the desired frequency and all others are rejected. This is called selectivity. To accomplish this tuning, you need only to change the value of inductance or the capacitance in the parallel LC circuits, that is the tuned circuits. For example, if you channel, then all you have to do is to vary these capacitors. In most cases, the capacitance is changed by the use of variable capacitors. The capacitors in the input and output portions of all RF amplified stages are ganged together in order that they can all be changed at one time with a single device, such as the tuning dial or a radio. But there are certain limitations of a TRF receiver. Selectivity must be established at the RF amplifier stage, which requires complex circuitry. The capability of designing highly selective stages over a broad frequency range is a difficult task, which becomes even more difficult if tuning is required. Thank you. Sources which took are mentioned in the slide.